Hello and welcome to this video, in which we will learn how to modify Katana 6's material soloing feature. When enabled, the material soloing feature allows users to isolate and view the output of a single shading node or a group of them in an interactive preview or live render. This can be really useful for fine-tuning a specific section of your shading network without getting distracted by the rest of the setup. It's worth noting that material soloing only affects interactive preview and live render sessions. Disk and batch renders will ignore soloing and render the final result. Let us now move on to the material soloing converter, which is in charge of converting the selected port's output into something that can be rendered. As you can see, not all node ports can be connected to the terminal port. This is because only surface type ports, like the one on this DL principled node, are compatible with the DL surface terminal port. In order to preview these non-compatible ports, we can implement conversion networks inside the material soloing converter plugins. Katana 6 ships with some default converter plugins for supported renderers, including 3Delight, Renderman, Arnold, and Redshift, which could be a great starting point to customize the soloing behavior. Let's take a look at the 3Delight plugin. We start by defining the base class, where we define some shared functionality that will be used by all of the converter plugin classes that we are implementing in this file, including the shading node type, which will be used by our converter plugin to check the compatibility of the port with the converter. Following that, we have classes that derive from this base class. This is where you implement the conversion of specific data types by creating a conversion node graph. The logic for this is actually implemented inside the create conversion network method. It takes in two arguments: a port from which the implemented conversion network will take its input, and a group node to place the conversion network nodes inside of. It then returns a tuple containing the starting port of this conversion network and a mapping of the terminal port name to the output port of the network. Okay, now let's look at how we can extend this plugin to add a new feature to, let's say, support a new port type. Currently, when a Place2D texture node is soloed, it doesn't trigger a render. This is because no converter is available for this port type. But what if we want to be able to preview and tweak the UV settings of this node? We can do that by implementing a converter that routes the output of a Place2D texture node through a checker and a surface shader node. We'll start by navigating to the directory that's being looked at by the Katana resources environment variable. Here, we'll create a new Python file inside a subdirectory called plugins, so it's picked up by Katana at launch. Next, we'll reuse the base class shipped in the example plugin. So let's copy it over to our new Python file and create a new concrete class that inherits from it. Again, we can utilize one of the concrete classes from the shipped 3Delight plugin. We can then modify it per our needs. Now, before we begin modifying it, let's figure out the port type we want to solo. Since it's an array float, let's start by updating the class name and docstring to reflect that. Let's now update the isCompatible method so our plugin only acts on array float type ports. If you want to further limit this behavior to the Place2D texture node alone, we can add another check in this method so this plugin isn't called by any other node. But for this example, we'll leave it here. Let's create the conversion network. We'll use the create shading node method to create a checker and a surface shader node, and then connect them together. Next, let's return a tuple containing the input port UV coord of the checker node and a dictionary that maps the output port of the surface shader node to the name DL surface. This will then route the output of the Place 2D texture node through these nodes. Finally, let's add this to the Katana plugin registry as a material soloing converter plugin. Let's take a moment to talk about the load order of plugins in Katana. Katana loads plugins based on the order they're appended to the Katana resources environment variable. So if we append 3 locations to the variable, say location 1, location 2, and location 3, it would load them in the following order. Location 1 gets loaded in first, followed by location 2, and finally location 3. Keep in mind that location 3 would override the other 2 locations. Now that we know how the load order works, let's launch Katana to see our plugin in action. Now, when the Place 2D texture node is soloed, the checker pattern will be displayed, allowing us to preview and adjust the UV settings. Of course, you can customize this logic to fit your specific needs. For instance, you might want to add additional nodes or tweak the existing ones. To reiterate, we provide example converter plugins for 3D-Light, Renderman, Arnold, and Redshift. Alternatively, you could also write a new converter plugin in its entirety if you're using a different renderer from the ones I've just mentioned. As you can see, it's relatively easy to extend the Material Solo Converter plugin to add new features and customize the behavior of the material soloing feature. I hope this example has given you some ideas for how you can use the plugin to better fit your workflow.